So today our lesson is on writing the equations of a line. We're going to be having to kind of do a little bit more work to get the information that we need. So just like yesterday's lesson, our final answers need to be in slope intercept form. And again, the only thing that's going to have a number substituted in is the slope and the y-intercept, because those values are constant for the entire line or equation, whereas the x and the y represents the many different points that could be on this line. So the first example here, in this case, we are given a point. So we're given just a random point on the line with an x and y value, and then it's telling us that there is a slope of 3. So the first thing we want to do is identify the slope, which is just given to us. So that's fairly simple, just m equals 3. However, the point that they gave us is not the y-intercept. It's just a different point on the line. And we know that because the x value is not 0. If the x value were 0, then the corresponding y value would be the y-intercept, but this one is not, just some other point. So because of that, we're going to need to find that y-intercept, and we're going to do that by substituting in the slope and the coordinates of this point into the y equals mx plus b and solving. So since that point is 2, 5, we're going to use the 2 for the x and the 5 for the y. So I'm going to do 5 equals the slope, which is 3, times the x value of 2, and that leaves us with one variable that we can now get by itself. So 5 equals 6 plus b, and then we subtract the 6 to get the b alone, and we end up with b equals -1. Now once we have the slope and the y-intercept, we can now write the equation of the line in slope-intercept form. So all we have to do is substitute in the 3 for the slope, and that should be a -1 there for the b, and that will give us our equation here, y equals 3x minus 1. Okay, so with that being said, let's go ahead and practice. So the first thing we would always want to do is identify that slope. The second thing we want to find is that b value, and then the third thing we want to do is write the equation in that slope-intercept form. Now in this case, the first step's already done for us. We have the slope there identified already as m equals 4. So then we're going to use the point that's given to us and the slope that's given to us, and we're going to substitute them into the slope-intercept equation. We have 2 equals 4 times 7 plus b. We're going to now use this to get that b. So 4 times 7 is 28. And now we're going to subtract the 28 to finish getting that b by itself. And we can now see its b equals -26. Now once we do that, we can now write the equation y equals 4x minus 26. Notice I did not put that x and y value back in. I left those as variables to represent all the different points that could be on this line, but the slope and that y-intercept are going to remain constant, so those values do go into the equation. Okay, the second example here, finding the slope, which is already identified for us as -1/3. And now I'm going to find my y-intercept by using the point that was given to me and the slope. So we have 15 times -1/3 times 9 plus b. Now the 1/3 times 9, when I multiply that, I'm going to get -3. So 15 equals -3 plus b. And then I add my 3. So I have 18 equals b. Then I go to write my equation, y equals -1/3 x plus 18. Okay, so now in the next example, we're going to still follow those same 3 steps, except this time we're going to have to calculate the slope. So this time the slope's not given to us, so I'm going to have to use the 2 points that are given to me and calculate the slope using that slope formula. So to find my slope, I'm going to do y2 minus y1 over x2 minus x1. This is going to give me 12 over 6, which simplifies to 2. So now I know my slope is 2. Now, when we go to find the y-intercept, we would use one of these points. Now, you have a choice. If you're given more than 1 point, it doesn't matter which point you use as long as it's one of the points on that line. So in this case, I'm going to use 0.39 because the numbers are just a little bit smaller. So I'm going to substitute in the 2 for the m, the 3 for the x, and the 9 for the y. So if I'm using y equals mx plus b, I'm going to put in that 9 for the y, like I said, 2 and 3 for the m and the x, and now I can solve for that b value. So 2 times 3 is 6, subtracting that 6, and now I have b equals 3. Now, had you chosen the other point up at the top, you would still get the same value for b. And then finally, we would write in slope-intercept form by putting the 2 in for the m and the 3 in for the b, and we would get y equals 2x plus 3. Okay, so let's go through the same process with a couple other examples. So remember, the first thing is to find the slope. The second thing to find the y-intercept, and then the third thing is we're going to write it into that slope-intercept form. So if I'm going to find my slope for this example here, 12 minus 8 over 13 minus 5 gives me 4 over 8, which simplifies to 1/2. So I have my slope of 1/2. So now when I go to find my y-intercept, I have a choice. I can use either the 0.58 or I can use 1312. I like to choose the smaller numbers just because I feel like they're probably a little bit easier to work with. So I'm going to substitute that into y equals mx plus b. So the 8's going to go in for my y. I have my 1/2 for my slope. Then the 5 is going to go in for my x. Now in this case, I end up with 8 equals 5 over 2 plus b. So I'm now going to have to subtract 5 over 2 from each side. So here's your options. You can do 8 over 1 minus 5 over 2 kind of over here on the side and just, make sure you get your common denominators and then subtract, and we end up with 11 over 2. Or if the numbers were bigger or a little bit harder or more challenging to work with, you could do it on your calculator. So if you were going to do 8 minus 5 over 2, you would just have to do parenthesis 5 divided by 2 parenthesis on your calculator. If you're using a graphing calculator, it will always default to the decimal answer, so then you can just go math, enter, enter to get it into the fraction form that's simplified. So now that we know that our b value is 11 over 2, we're going to write our equation y equals 1/2 x plus 11 over 2. So now we'll do another example. Okay, so for number 4, I'm going to find my slope. I'm going to do 5 minus -7, and then -3 minus -6. Remember, whenever you're subtracting a negative, that's really addition. So this is going to be 12 over 3, which equals 4. So my slope is 4. Now for this problem, I'm going to use the point -35. The numbers are a little smaller and only one of them is negative. So again, plugging into slope-intercept form, I'm going to use the -3 as my x and the 5 for my y. So 5 equals 4 times -3 plus b. 4 times -3 is -12. And we'll add 12 to each side. So b will equal 17. So then writing my equation, it will simply be y equals 4x plus 17. Now, in the third example, we're going to continue on working with the same type of problem, but this time they're going to be written in function form. So if you remember, we've talked about this before, that f of x is really equal to y. So if it says f of 2, that means 2 is my x value, and if it equals 3, that means 3 is my corresponding y value. Same thing for this example here. If it says f of -3, then the -3 is my x value, and then that 8 would be my corresponding y value. So because of that, then we know that f of 2 equals 3 is really the ordered pair 2, 3, and f of -3 equals 8 is really the ordered pair -3, 8. So we can just use these two ordered pairs to do our equation. So now we're going to calculate the slope just like we did on the previous example. We just had to kind of look at the information in a different way. So I'm going to do y2 minus y1 over my x2 minus my x1, which is going to give me 5 over -5, and that simplifies to -1 for my slope. Now when I go to find my b value, again, I have a choice of these two different points here. So I'm going to just choose 2, 3. Since there's no negatives, the numbers are a little bit smaller. I'm going to substitute in the -1 for my slope, the 2 for my x, and the 3 for my y. So I have 3 equals -1 times 2 plus b. Of course, -1 times 2 is -2. And then I'm going to add that to the 3, and I get b equals 5. So once I have the slope and the y-intercept, I can now write the equation in that slope-intercept form. Now when I do that here, I'm going to substitute the -1 in for the m and the 5 for the b, so that would be y equals -1x plus 5. However, because the information was given to me in that function notation, I'm going to make sure I put my answer in function notation as well. So f of x equals -x plus 5. So you're just going to replace that y with that f of x. So doing these two examples then, first thing I like to do, just to make it look a little more familiar, is to get the numbers out of that function notation and just rewrite them as an ordered pair so that they look a little more familiar to me. Now I'm going to find my slope, y2 minus my y1 over x2 minus x1. This is really -7 plus 4. So this is going to give me a -3 over a -6, which is going to simplify to +1/2. Now, picking a point, I'm just going to pick this first one here to find my y-intercept. So -4 equals 1/2 times 2 plus b. Now, 1/2 times 2 is just 1. And then I'm going to subtract that, and I have a -5 for that b value. And now I can write my answer, which would be y equals 1/2 x minus 5. But remember, we want to put it in that function notation since the original information was given to us in that way. And my answer would be f of x equals 1/2 x minus 5. And one more of these. So again, rewriting this as ordered pairs, -5, 17, and 3, 9. I'm going to go ahead and find my slope. This time I'm going to do y1 minus y2, since I like to do the 17 minus the 9, then -5 minus 3. So that's going to give me 8 over -8, which simplifies to a slope of -1. Now I'm going to use 3, 9 to find my y-intercept. So 9 equals -1 times 3 plus b. And now I'm going to have to add 3 to each side. So b equals 12. So now when I go to write my equation in slope-intercept form, I would have -1x plus 12. But of course, we're going to put that into our function notation. So f of x equals -x plus 12.